Hello and welcome to my new episode of my tutorial series how to create a fantasy weapon for video games. Today you will learn how to bake your normal map information to a low poly mesh that we have created in the episode before. So here is in the sculpt room, here you see the high poly mesh, and this mesh was now baked to the paint room, which can be found here. This is our paint room mesh, and it looks exactly like the high poly mesh. And I switch the wireframe on here. Here you can see it, and you will learn today how to set the right settings to bake the normal map information into a texture here for a template to paint later on it. Okay, thank you very much and have fun. Okay, let's go. Here you see my model from the last episode, and in the last episode we have finished our UV information for this low poly model for the game, and this UV information will be today used to bake the normal maps from our high poly model. As you remember, this is our high poly model, and it has some structure like this elements here and this pattern, and we will bake today all this information to the normal map of this low poly retopo model. Some information before I do this, before I'm starting, I have switched to version 4.1 in the meantime. All my recent tutorials were made in the version 4.0. The new version, or the version I'm using today, is 4.1. It is available for use since March 2014, so it's a long time ago when it was released, and I think that most of you are already using this version, and I thought it was time to switch to this version because some bugs are fixed and some things are made. Some menus changed too, so you don't have you have this elements here: bake selected, import course mesh, and all this stuff, baking, scan setting. All these elements are now in a special bake menu. Before this update, or before one of the updates here, these elements were in this menu here, down somewhere here, and now Pilgway has splitted these menus to a special menu only for baking. So this is one of the main changes here, and some additional small changes were made on the unwrapping routines. Before this update, you had two or three unwrapping routines. It was ABF, the LSCM, and the planar routine, and now you have two more. There is the close relax routine and the GU. The global uniform routine is a proprietary routine that is only available here in 3D Code, and close relax is the same. It's a special routine for clothes, as you see. So if you have some elements that are going to be close, then you should use this one. But don't forget to try your to unwrap with the other routines. That's important too. So these new routines help us to improve our UV information a little bit. So when I'm clicking on this island and this one and using now the GU routine, it works much better. There is much less squeezed elements. The same I do for this one, GU, and this one to GU. Now it looks much better. It's not so much problems. Additionally, the LSCM routine were overworked a little bit, so you see here is our LSCM object. I make it a little bit straight, so, and you see here is a little bit red and blue elements, and when I'm selecting on it and say LSCM again, then it changes a little bit. And now it's better than before. This I've seen in my model. This element here is not really good working with GU, and it's not working with ABF in the current version. I don't know if it's a bug or something like this, but I will not correct it. I will stay this element like it is. So now I make an auto scale again, and now all elements are rearranged, and I can use this UV information for baking. And this is what I am starting now. We go to the bake menu, and the easiest way to bake something is here to say bake into scene and with normal map in the per pixel mode. This is what we used later to work with. So the per pixel mode here, this three parts, this area, this is a regular mode to paint on the model. So there you are painting on textures and not into vertices or other elements. Here in the p-text mode, this is a special mode to bake your information into a p-text texture. So in this way, your UV information will be splitted into a p-text UV map, and then you can use your informations and paint with p-text. This here is or pixel texture, no p-text. This here is baked into the scene with the micro vertex mode. The micro vertex mode in 3D code is nothing else than painting on vertices. So what you are doing there is you paint vertex information into the scene. So you're baking all this information into the vertices. There you will have two models at least. 3D code is then working with here in the micro vertex. It's working with two models: a cage model that is represented by your retopology model, and a high detailed model that represents your height maps. I don't want to go inside into these modes and don't explain you them because it would take a lot of time. So what we need is just here the normal map information in the per pixel mode. So what I do now is I click on this element and a new window appears, and now you see you can set some elements. Important before you are starting to bake or you're using these functions, be sure you have switched your high poly model here in the box tree on, because all elements that are not seen can be baken into your low poly mesh. So if you switch some of the eyes off, then here the layers, then this information cannot be baked into your texture. So here you have some new elements, some new options. Scan depth. What does it mean? You have seen my high poly Warhammer has structures, has depth elements, have depth information like these patterns, and here the ropes. I show it to you at here. And when I'm going into this mode, my retopo model now is a little bit bigger. It grows out and shows me the calculation area, how far 3D code calculates normal information to be used to our texture. So what does it mean? It means all that is in this model or in this area here included, all this information will be calculated to our normal map, and all information that is not included will not be calculated. Then you will not see normal map information, you will see instead black areas, for example. To control this size here, you can use these values. At the moment we show the outer shell. The outer shell is the outer calculation distance, and here when I click on preview inner shell, this is the inner shell distance, so the inner distance that is used to calculate, because some elements are inside. So you can see maybe here is a little bit seen of our cage, of our inner cage, so it's going into the model. So be carefully with your settings. What I do is I start to change here from 10 to 5, and now see some of the calculation. I hope I do another value of 1, and now you see the inner shell is going not so far into the object, and this element here that you are seeing, this color, this element will not be calculated. So it's important to increase the value as long as you are not seeing these elements here. So and what I do is I try to get the right value. So here are some elements that can be seen. I don't use very high values here for this, because it can result in bugs, in problems later when the inner catch is too far in the object. That's all what I want to say. So I take now the 5. Good. Now I show you the outer shell, and there I'm starting at the value of 5. This is completely enough, so I reduce it a bit. Here you can see this element will not be calculated, so you need a bigger value, and the same could happen here at the rope. So I will use a value of 3. Here you can see this element will not be collected too. And now I do a value of 5. This is very important when you are working with tight elements, where you have model parts that are too tight or too not far away from each other. So here you see we have some problems with this area. So what we need here is a little bit more distance. But the distance here is completely okay, and actually it's not good that these elements are overlapping. So what I actually need is a smaller value at all. I will use a value of 4, maybe 3.5, and now it works here very good. No, a bit more, maybe 4, no, here, 5. So what you can do now is you can change this. You can change the values locally. To do this, you can add zones, add value zones. So what I do now is I add a zone here, and here is our small sphere. It represents the calculation zone that is used here in this area. The area is limited by the diameter of your sphere, by the size of your sphere. I click directly on the sphere and I move it here to this position. You can see here is some parts are here not very well, and they will be not recalculated. But here is all right, and the same is here. So I move this one to this position and say here in this sphere area the radius have to be 6 of the sphere. What I mean is the radius of the sphere is 6, and no, I take a bigger one. So, and everywhere where you see the sphere, again 10, everywhere where you see the sphere, these values will be taken. So the in depth, this one, and the out depth will be taken here. So what I say, out depth will be now 6, and now you see the mesh here grows. I do it again to 4. This is 4, and I say 6, and the mesh grows at this area. The same I will do here in this part. I will add a new zone, this blue one, and move it to this position, and say the radius is 50, for example. It's too much, I take 40. No, 50 is okay. So I move it to this. That's a little bit a small problem here in this version. When you change the value here and move then your zone, then the value will be resetted to the main value. That's a little bit, yeah, problematic, but it's okay. So I will change it again to 50. Now I use a new value, 6 for example, and you see my mesh grows here, and I take a 7 to make it bigger. Now you see only here the problems for normal baking are avoided, or are gone now. So I make a new sphere, a new value to reduce the problems here in this area. Add a zone again, move the zone to this element. Okay, maybe here, and change it to 50 again. Maybe a little bit more to reach this element here. 75, and say they are 72. Now you see it works much better. and the problems are a little bit gone. So yeah, that's good now. That's not bad, but I guess I move it a little bit to the right and do the same again. I make 80, and now the problems with the normal maps will be solved here. Good. Now I go to the next step. I can choose a method for baking. You can use the snap to the closest along normal. This is a regular mode. It needs not so this much time like the other one. Snap to outer surface is a better calculation. You can try which one works better for you. So I use the snap to the outer surface. It's okay, but maybe there are some models where you need the other mode. Now I go to OK, and the next step in the baking process is you could bake local occlusion. Yeah, the local occlusion is just the ambient occlusion that is used for this model. So it's not only an ambient occlusion. What there will be calculated are the sharpen edges too. So you will see there are white elements where the edge is a little bit sharper. So you can set a value for it. Smaller values renders smaller details, and bigger values renders big details, smaller detail. So I will take a value of 50 and bake local occlusion this time. You don't need it every day. The point is, I'm honest. 3D code is not calculating very good ambient occlusion. If you can use XNormal to calculate your ambient occlusion information, because the XNormal is doing this part much better. The tool XNormal is for free. You can download it and use it, and I will show it to you later because I will use XNormal for correcting some normal map problems. Okay. Now I say OK, and now came the last dialog. Here you define you define here the options for the paint room. So you say what the model have to be prepared in the paint room. So what I do is I say texture width and texture height. So I say it's 2K. It's always good to use a bigger texture, because you can always calculate your texture down but not up. So I do, and in this case I use a texture of 2K. You can change the width and the height, so you can use another height for the epsilon, or for the height, another size for the height. But you can, if you like, create a custom texture size. So for example, if you are using here a different one, so you can use the custom texture. Here you are not forced to set something, but if you know which software you are using later, for example, if you are using Blender, or if you are using your normal map for Blender, then you choose Blender, and here you have some more applications where you can set the normal map settings for. You can use Unity, the Unreal Engine, ZBrush, and different other settings for the normal map information. At the moment I use unknown, but this one will be used for the regular setting. So then you can set a subdivision, but this is not good for our model because we are using this pure model in our engine later. We don't need subdivisions. Then you can keep the UVs. That means the UVs that you have, which you have set here, the UVs will be kept. If you say auto mapping, then new UVs will be set and the old UVs will be gone. So keep the UVs. UV set smoothing. Smoothing means the UVs can be smoothed. The UVs will be corrected to your subdivision model. It's very important if you are working with characters for feature films, for example. When the most characters are modeled in a low poly version, and then they are subdivided to have very smooth and nice characters. And when you are subdividing a character and you have UV information on this character, then the UVs will be stretched. And here in the UV set smoothing, you can decide which mode have to be used to avoid stretching, or to make the stretching less problematic. So these are the modes to use for. This is not important for us because we are using we are creating a model for games, but so I let it to no smoothing, and that's okay. These options are not very interesting for us today. You can swap the axes if you like, and all this stuff. You can weld vertices. This is not important. Invert normals and so on. I say no center snap. That's okay. And here is the auto smoothing groups. This option will be interesting later, maybe. What you do here is you can set an angle, a maximum angle where a face becomes sharp, or an edge becomes sharp. So what does it mean is all edges that are not that have an angle of under 30 will be not made sharp when I'm using this. This is very interesting for my German tutorial, because there I'm using a war axe, and there it helps a lot to bake the normal map information. And if you like, you can take a look into my German tutorial. Maybe it helps you to avoid your problems if you are building very sharp objects. At first I switch this off and start the baking process. It needs a little bit time, but my model is not this big, so I hope it will be fast. Here we have it. I go now to the paint room. 3D Code moved my model directly to the paint room here. These black elements are not a problem. It is just the box tree. There is a model to scene, so I switch it off, and now the model is gone. For any reason, my hammerhead is completely black. I can't say to you why. So to check this, I will switch all my informations off. And now you see I have here are some new layers created. The occlusion layer that was calculated, a normal map layer, and information for the elements. This is important because if you like, you can set materials in the sculpt room, and these materials will be calculated, the colors will be calculated into these layers. So what I do now is I will control why the object is problematic. So I switch the normal map on, and I see my model is not complete. So the hammerhead normal map information is not here. Something is wrong with my hammerhead, and this is a point where I will check why this happened. So I delete first my existing layers, but the layer the layer O have to stay always. You cannot delete it anyway. And now I delete my new model here. So it's here in my sub-objects menu. You can see these are the models here in the paint room, and you can delete them by clicking on this element. So you have to delete them before you start a new baking process. Now I go back to the Retopa room, and here is my element. So now I look why my model is not baken, or why the hammer is not baken. I think it could be the options here. Name correspondence for baking. This option were switched on. Maybe I have used it for one test before and I forgot to switch it off. This option says only the models will be, the Retopa models will be baken that are corresponding with the model name of your voxel room. And you may be seeing my hammerhead was not included into the baking process. The reason for this was here my group, my hammerhead retopo, has the name hammerhead here, and my hammerhead in the my source information, my high poly mesh in the voxel room has a different name. So here you see it's hammerhead with the underscore. So what I do now is I can change and correct the name here, or I can correct the name here. It's completely no problem. And now when I bake to name correspondence for baking, everything will be baken in the right way. But I would like to show you first what happens if you don't use this option. When you don't use this option and you start the baking process, all will work, but there is some elements that are not really good. So I show it to you by using the baking process again, and now I do bake with normal map. All my elements, all my settings are here as before, and I say OK, 50, OK, and now I use the map size and say OK, 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 and now start to bake. And again, it needs a little bit, but will be finished in some seconds. I hope you have the time for waiting. Good. Here we have it. I go back to the paint room, and now it looks much better, but as always you have to switch the voxel tree, the voxel model, you have to switch it off. Now we see just the baking result. It looks very nice, and I show you what happened. When I have here, when I go to the sub-objects, I move the sub-objects window here to this position to see them always. I have now my sub-objects. Here is our object for the cord, here is the object for the handle ring, and the sphere, and the handle itself, and the hammerhead. So, and I show you the information, just only the normal map information. To see this, I just press one key, or I go here to this and say relief only. Relief only means I see just the normal map information. This is this layer here. Switch them off, I see this, and when I switch it on, then I see this. Now you see, when I switch the hammerhead off, then you see we have some normal map information here in our handle elements. That's not very nice. When I switch my hammer on, then I see it again, and I see I have some information in my hammerhead. So when I switch off the handle, I see some of the handle, some normal map information was baken into my area of my hammerhead. I show it to you in the map. I open the texture editor. You will find the texture editor here under textures and texture editor, and if you like, you can set a controls shortcut for it. And here we have the map, and what I see now here is this is the color information that we can see when I see the normal model, the regular model. And what I want to see is not the color information, I want to see the normal map information. Here is the normal map information of our model. And now you can show the wireframe if you like for the whole model and see the model. I cannot see the wireframe information of my handle because my handle is switched off, it is hidden. Now I can see it, and now it's off. So what I want to show you is here this area of the hammer, and the hammer area is here. It's this position, I think. Yeah, I can test it by clicking here on the normal map ball, just the normal map, and paint a little bit here. Oops. I guess I have the wrong. Yes, I cannot paint on the calculated normal map, so I take a new layer and paint here a normal map. Okay, it's the wrong one, but I will find it. Where we have it here. Here is it. No. Here. Okay, this one. Here you can see I'm painting on the model and see the normal map information. So what I see is this element or the handle was calculated into our element here. I don't want this. Maybe this is not very problematic at this element, at this area, but when you are moving down, you see where the chord is. There is a lot of information in our handle, because everything was calculated more than once, and not only on the model. So some information from the handle is now in the chord. Some chord information, as you have seen, is in the handle, and this is not what we want to do. What to have later, then we want to paint directly on the handle and not on the chord. And the same you will see is here for this ring. Yeah, handle ring. The ring is baked into the handle, and that's not nice. You can avoid this in 3D code, and this is the reason for our mode corresponding names. So what I do now again is I delete all my objects, and I delete the maps information. Okay, now everything is now reset to the normal to the default settings, and now I switch my high poly mesh on to see it later on my baking. What I do now is I bake, but I use this option, name correspondence for baking. Okay, and I correct my name, the name of my hammerhead, to be the same. This is very important. If you forget this, the informations will be not baked into your model. Very important. So the other ones are okay. Handle ring is handle ring, and the sphere is the sphere, and the handle is the handle, and the chord is the chord. Looks good. Very nice. Great. Now I start again to bake the informations, and again to normal map. All is okay. Okay. Again my occlusion. Okay. 2K, and bake now again, but this time in the corresponding name mode. I say you should use it always. You should always bake your models with the bake name correspondence for baking mode. It's much better, especially when you are working with sub-objects. So now I switch here, and now it looks much better. I switch the grid off. Here you see our chord. I switch to the normal map mode. Our chord looks very nice here. When I switch it off here, the chord, then I see only the handle, because every model, every normal map information is just baked into the other ones. This is very interesting. For any reason, the handle ring information was baked into the handle. Oh yes, I know why. Very easy. When I switch back to my room, then I see one thing. My 3D code is working with hierarchy, so the baking process is based on the hierarchy too. So here you see when I hide the handle, this is the handle, and inside the handle, in the hierarchy, there is a handle ring. This means all that is used here in the handle will be baked into the handle. Okay, so when you use here a different name, for example, handle ring without the underscore, then it will be baked into the handle for sure. So you don't have to be aware of this. But in our situation, we don't want to have this, because I don't want to have the ring information in my handle. So what I do is the same for the sphere. I show it to you. The sphere has the same problem. Here you can see it. When I switch handle off, you see no, the sphere not directly, but the handle. You have the sphere information in the handle. That's not nice. So what I do now is I move my handle ring to the root here somewhere, and the same for the sphere. And now these elements are not in the hierarchy of my handle anymore, and they are individual and will be calculated individually. So okay, I will do the same again like before. Delete, 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 delete. Unfortunately, I have to delete the layers separately. They will be not deleted automatically with the object. That's okay, because there is no link between them. That's good. That's not a problem really. So I switch now my information, my voxel mesh here, and now again go to bake. The same option, normal map. Okay, okay, and 2K. Okay, and start baking. Okie dokie, here we are. I switch my high poly mesh off, go to the paint room, and now all should work like it have to be. So when I switch my chord off, then I don't see any chord information. The same for the ring, and the same for the handle, for the sphere, and I have just the information for my handle, my normal maps here. And when I switch the handle, the hammer have off, then I see only the handle, and the same with the handle. I don't see anymore this circle here, and this I switch my axis off. Yeah, and all is very fine, very nice. Here you see everything is working very good. So this is first the normal way to, the regular way to bake normal map information for the paint room, and now we could start to paint onto the hammer. Yeah, maybe one thing more. Here is our baked occlusion information. You can use it. I switch to the flat shade mode, and here you see this information, and you see here are some structure. It came from the calculation method. So as I said before, try to use X normal to calculate your ambient occlusion, because 3D code is not very strong in this area. Here you see some bugs. These black areas came from our baking settings. This is the reason why it's why this is all black. So you should check your model if there is some overlapping. So you should go there and check them. So what I do is I don't need this ambient occlusion here, because we will paint the information later by hand. So I delete all the layers I'm not using or I don't need. The hammerhead layer is not interesting because we have no color information from our voxel materials here. So as the same here for the others. Very important, don't delete this one here, the normal map, because then you have no normal maps. So great, I delete them, and now we have the model, the basics, or the default, the template for our painting. We have a very nice result and very nice template for painting texture information on our hammer, and I will continue my tutorials in the next episode, and then I will start to paint texture information on the hammerhead. I hope you liked my last episode here, and will watch again next time. Thank you very much and have a nice day. Bye bye.